Hello, everybody. Antonello was speaking. I'm one of the general chair of this ISMAR 21. With a great honor, I'd like to give a kickstart of this ISMAR event. And we'll be starting with a great tutorial, Introduction to Augmented Reality, Interoperability, and International Standards, which is a great topic. You know, if we really want to move augmented reality techniques to the plateau of productivity. So let me introduce Christine Perret, who will start this tutorial, and that's it. I wish you a great ISMAR 21 for this week. See you later.
So I think we just lost our chair, but she was here just a moment ago, so I'm sure she'll be back in just a second.
So in the meantime, while we wait for Christine, maybe I can just spend a couple of minutes introducing you to this event. We'll be having the principal core of the event starting from tomorrow. We'll have the opening ceremony tomorrow morning, and we'll be running through 3 days, very dense of activities. So make sure you attend the opening ceremony tomorrow morning at 8:30 Central Europe time. So we'll be disclosing some cool things that are going to happen. And we'll have today and Friday packed with tutorials and workshop with a lot of information for everybody. So make sure you attend the most you can, because this year we have a great program. Let's see. Oh, here we are. I think Christine is with us now.
Hello.
Yes, hello.
I'm sorry,
hello.
I lost our internet connection all at once. Hello, can you hear me?
Yes, sure. Welcome back, Christine. So
I
just finished
power and
introducing you.
Okay.
Please.
Thank you. Thank you. Unfortunately, I will not be able to show my video as I'm using my phone as a hotspot, but I hope you can see my slides.
Yes, we do.
Thank you. So welcome, everyone. It's my pleasure to be here and to share with you the interoperability and standards tutorial material that we have been preparing for you. And I'm here with people, some experts who are going to introduce themselves in a moment. and we're going to speak and follow the agenda that we have published on our website, and hope you'll enjoy what we have to share. So for the next few minutes, we will be making general introductions, and then we'll present for a couple of sessions to talk about the problem of interoperability, what happens when you don't have interoperability, and how you can increase the interoperability not only within AR systems, but between augmented reality and IT systems wherever you are. We'll also be I'll give a short presentation about the current standards status, and I'll tell you more about that. We have a presentation also by Bill Bernstein on basically a case study, several case studies of how to use standards as tools in the manufacturing setting. So we will be able to hopefully go through this tutorial without too much interruption. So that's our agenda today. I'd like to welcome the other panelists and people who have helped to prepare this. Neil, would you please tell us a little bit about yourself?
Sure. Hey, Christine, I'm very impressed you're doing this from your phone. Let me know if I have your slides. If you need me to present them, just let me know. Yeah,
but
hey,
you were able to see them. You were able to see them so
yes,
far.
Looks perfect.
Okay, great.
Looks perfect.
Thank you.
So, hey everyone, I'm Neil Trevitt. So my day job is at NVIDIA. I do developer ecosystems there, helping developers get to use GPUs. But I'm here today representing the Kronos Group, which is an open standards organization. I'm currently the elected chair there, and we've been working for many years on standards for augmented reality.
Muriel?
Okay, yes, sorry. Hello, everyone. My name is Muriel Deschanel. I'm the Standardization Director at BICOM. So BICOM is a private research and technology institute based in France with a range of expertise in artificial intelligence, image and sound processing, immersive technologies, and 5G. So I'm the elected chair of the industry specification group called Augmented Reality Framework at ETSI, and I will tell you more about the activity of the group and how it aims to increase interoperability for AR solutions during my talk later on. And it is my pleasure really to participate in this tutorial and present to you this morning.
Hello, everybody. My name is Bill Bernstein. This past month, I just joined the Air Force Research Laboratory, which is located at Wright-Patterson Air Force Base, right outside Dayton, Ohio. But most of my work that I will be sharing today has been outputs from my stay at the National Institute of Standards and Technology for the past 6 years, where we focus on how we can bring new visualization tools to the manufacturing and design ecosystem. And we've really found the outputs from the standards community, from the folks like Muriel, Neil, and Christine, what they've done in the past have really helped us push forward quite quickly. Really excited to show some of those demonstrations. Great to be here. Thanks.
Thank you, everyone. It's a pleasure, and I hope that we maintain good relations and over the course of the week that we can have discussions with people through the Discord channel. So I'll go ahead and get started. And I think, you know, a long time ago, people didn't understand that interoperability was a goal or why it would be a good goal. So I'm going to review, and I hope that some of this is familiar to people, because we're more and more aware of the benefits of interoperability, but we don't know exactly where the challenges are. So this image is not actually the AR landscape. It's a landscape of edge computing, but I think it's illustrative because it has so many small boxes. As you can see, there are also some areas where there's 20, 30, 40 companies all together competing in one segment, but what I think is interesting is this is similar in complexity to the augmented reality ecosystem. And according to some research that was recently done, there are over 500 companies who consider augmented reality to be their sole focus or a very important strategic component of their business. So it's nice and neat and looks like there's these lines that cut between segments and subsegments, but in reality, the situation is much, much more complicated than that. And companies are always positioning themselves to look for opportunities. And companies are composed of people. There are, of course, business people who are managing the revenues. There are developers. There are people who are building systems or components. And yes, they have customers, so they have end users. And there's so many stakeholders. They're summarized in this image. The AR ecosystem is complex, but it mirrors other ecosystems that we might be familiar with in electricity or transportation or other domains. So as in those other domains, interoperability is important, but I want to define it. And this has been a long process, and we're always trying to get clarity about these definitions. So it's the ability for component systems and software, whether those components are hardware or silicon or full displays, it's for all of those segments that enable augmented reality to be able to communicate and exchange data. And why do they want to do that? For users to be able to have AR experiences, to visualize in context the information that these systems have made possible. But we can't imagine a day, I can't, where there's only one provider of augmented reality products and content. So there will always be a high diversity of providers. And we need to be able to communicate and to exchange information without translation conversions or delays. So I've created a series of figures that explain for you how I see this. So there are these AR systems and services. In this box that you see, these cubicles, you'll hear a little bit more about them a little later. But what's important is that they show the interfaces with the real world at the top, the physical and digital interfaces with the real world. And then the tan boxes in the middle are what some people call middleware, but what they are is enabling technologies that support the production of augmented reality experiences and the acquisition of context. What is the user's context? And then interpreting that context and in the world analysis and providing experiences in a seamless way. The turquoise boxes on the top, on the bottom are other modules and services that are all necessary. And as I mentioned in the figure with all of the tiny little boxes, this is a multi-vendor solution. And these systems and services don't get provided by one monolithic silo. And they don't get provided in just one form factors that we can expect that there are today tablets and handheld systems. There are projection augmented reality. And of course, the vision we share is that one day we will be able to use augmented reality anywhere in a hands-free way. So there's also the vision that we'll be able to use augmented reality everywhere, regardless of where we are. And that in those venues, the home and the work and everywhere, there will be other users who themselves have other technologies, and there will be technologies in those environments in the museum or the workplace. And the data that's roaming around, that's being used by all these users in different places need to be able to align and to provide value when and as needed. So the expectation is all these different types of data can be integrated. And so how do we do that? Well, you have to integrate not only the data types, but the formats and the exchange encodings and so forth. So we need to leverage, not recreate existing diverse infrastructure in order to be able to send the data, share it, control it, and give instructions to users if and when they need them. Now, what are the benefits to all this? This is the why interoperability. Well, there are 4 key goals. Of course, we want to increase the adoption. So we want to grow the market by reducing the customer confusion, increasing capabilities and usability. We also want to have rapid innovation. People want answers to their needs or their requirements as soon as possible. And the providers want to implement systems in a quality way, and they want to have the highest performance at the lowest cost. Everyone wants to minimize and reduce their costs, not only their costs of operation, but their time and cost of development, accelerating the time to market so that they can meet the specific needs and gaps in the ecosystem. To achieve this interoperability, we can summarize and say there are 3 sets of tools, not just one tool. There's different approaches that we'll be talking about today. One of those is standards, and we'll concentrate to some extent on those this morning. And then there's also open source libraries, and the industry groups play an important role. But why are there so many different standards, so many standards, organizations, industry groups, and communities? Well, they all have different expertise, and there's different people participating in those. And the different groups also differ in how they protect the intellectual property and how they develop the libraries or standards. Having so many different groups that you'll be hearing about shortly presents some risks. There can be duplication of work. There can be standards that in and of themselves are very good solutions, but they don't interoperate with other standards and other systems that have developed diverse specifications. To reduce these risks due to this very, very complex standardization interoperability environment, we have to have members that have position and roles in multiple organizations, development of liaison agreements between groups and standards groups, and to share information like we're doing with you today. And eventually we expect to have a high degree of participation, not only in the implementation of existing standards, but also in the development of new ones. So standards development organizations, as I mentioned, differ in how they work. So there's a range from completely closed, very limited participation to completely open, where non-members can contribute if they choose. There are many liaisons, but in a way one can say not quite enough. There need to be relationships between all of the different standards organizations and groups, because that's how we're going to eventually develop consensus within groups as well as between groups. And some of those specifications will be sold for a fee and others will be made publicly available. We should never expect a monolithic or a even landscape. There'll always be diversity, and that's a good thing. And that's where I'd like to end my introduction about what the problem is. And you'll be hearing more about approaches that Kronos Group and the ETSI have developed to counteract the risks and to reduce those risks of fragmentation. Now, turn it over to you, Neil.
Cool. Thank you. And we have the panel session at the end for questions, but in the meantime, feel free to put questions in either the chat or the Discord channel. And we can either answer them there or pick them up in the panel. So can I see my screen okay?
Yes, see it perfectly. Thank you.
Great. Okay, cool. Hey, everyone. So yes, thank you, Christine. That was a really good overview of why standards are needed and industry landscape.
Yeah.
Around
Can you give my phone back, please?
Yep. Can you hear me? Yep. Okay, so I wanted to amplify 4 topics that Christine touched on. Firstly, the difference between open source and open standards, and some of the principles that we have found at Kronos that makes standards successful, and then a quick look at how open standards are constructed at each stage of their life cycle, and lastly, how standards organizations in the industry are working together. And fair warning, I'm going to use the metaverse term a few times in this presentation, but don't panic. I only use it as an example of a great AR use case that's going to be needing lots of interoperability to work through open standards. So let's dive in. Firstly, to set some context, if you haven't met us before, Kronos is a non-profit standards consortium. We're open to anyone. All our standards are royalty-free for the industry to use. And our focus is on enabling applications to access the power of 3D graphics, virtual and augmented reality, and parallel computation. Last year was our 20th birthday, and we have over 180 members from around the world, from the largest companies down to small startups. So let's start with some basics. Interoperability standards have always been the foundation on which technologies are made available to society at pervasive scale. So, for example, the ubiquitous PC is built from a web of literally hundreds of hardware and software standards. And indeed, the act of plugging your PC into the wall outlet takes another whole interoperability ecosystem that has become so ubiquitous that we just take it for granted. And if we're successful, technologies such as augmented reality used to build what many are calling the metaverse will eventually also become so ubiquitous that people take that for granted too. But bringing together so many diverse technologies at a global scale is going to take really an unprecedented amount of interoperability between different platforms and products. And that means we need a strong foundation for cooperative standards from many standards organizations. There's going to be no other way to make the metaverse a reality. But before we do a deep dive into standards, we should, as Christine mentioned, remind ourselves that open standards are not the only way to drive industry cooperation. Open source is also a powerful tool to move the industry forward. And open source and open standards are very complementary and almost always leverage each other. But the two we find are often confused. So I'm going to try and differentiate them. An open standard is a shared specification with conformance tests that enables multiple implementations to be built and shipped by multiple companies. And that helps a technology become pervasively available and propelled forward in the market by innovation from competing implementations. Now, truly open standards are not controlled by any one company. They are created through industry cooperation at standards organizations with well-defined multi-company governance and intellectual property frameworks. And as Christine mentioned, there are many standards organizations, each with a specific area of expertise. Now, open source projects, by contrast, enable multiple contributors to cooperate over building a shared implementation. So creating engines and applications that could often not be built by any single company. And as we build the metaverse, open standards can provide the broad connective tissue for a foundation on which both products and open source projects can thrive and innovate. And actually, again, before we go into open standards, industry cooperation is not always the answer to every problem. Proprietary products, for example, are much more effective at driving the Darwinian evolution of new techniques and technologies. And successful innovative products can remain dominant in the hands of a smart market leader. Effective standardization only emerges when there is a recognized wider need for a proven, well-understood technology, and the industry is motivated to cooperate on reducing fragmentation. And if you take the long view, And an open standard that is not controlled by or dependent on any single company can be the thread of continuity for sustained industry forward progress as technologies and companies and platforms and markets all swirl and evolve around each other. So we shouldn't try to create standards too soon before technology is well understood. But of course, there are already many metaverse components that are understood, and standardization is underway. So let's talk about standards. Successful standards are built by the industry through achieving open consensus, and they're built for the entire industry to freely use in the best case. There are many aspects to a standard being open. Firstly, anyone should be able to have a voice in its creation, with transparent and well-defined processes to generate genuine consensus. Secondly, design decisions should be made on technical merit, with no one company controlling the technology or the standard's evolution or dictating where the standard may be used. And being free means that there is no charge, ideally, to access or use the specification. And probably most importantly, it means there's no patent royalties to ship products that implement the standard. And the success of any standard is ultimately measured by how widely it's adopted in the industry. And that's achieved by adding real world value to companies in the industry. At Kronos, we have found that industry adoption of any standard requires significant investment in its tooling ecosystem. A specification without conformance tests and development tools is not really a standard at all. It's just a document that will soon be forgotten. So how are standards made? I'm using Kronos as an example because I know it. Kronos is a standards consortium that has multiple standards that are being widely adopted in augmented and virtual reality markets. And these include 3D graphics APIs such as Vulkan and WebGL, and the OpenXR API for portable access to XR hardware devices, and Gltf as a runtime optimized 3D asset transmission format. So how does a standards body organize to manage multiple standards simultaneously? For Kronos, the answer is each standard is managed and evolved by a working group that is made up of any Kronos members that wish to participate in creating that standard. Many working groups have advisory panels of invited industry experts that can give input and feedback to the working group with no membership fee. And each working group produces a specification, of course, but also a whole bunch more that makes a spec into a real standard, such as the conformance tests, the SDK tools, user guides, samples, and educational materials, just as an example. And typically all these materials are placed into open source, including the specification source on GitHub to enable bug fixes and feedback from the wider community. And companies that implement a Kronos API pay a one-off fee to get access to a Kronos adopters program, so they can submit the results of running the conformance tests, and if successful, they become officially conformant. And once they're conformant, adopters can use the API logo and trademark and are protected by the patent licenses from Kronos members and other adopters. So application and engine developers then use those driver API implementations. And of course, there's never any charge to developers for using any Kronos API. So that was a super fast one-slide overview. I'm just going to dig down into a couple of places in the process to see how standards work through the life cycle stages, from its initiation through its creation, through consensus, the IP framework that enables it to be implemented royalty-free, and then how it becomes officially conformant, and finally how the tooling ecosystem around the specification is built to drive industry adoption. So first, how are new standards initiatives created? Kronos welcomes requests from anyone in the industry, not just Kronos members, to establish new interoperability initiatives that may create new commercial opportunities for the industry. Kronos uses a well-established new initiative process to enable broad industry input into the potential value and scope of a standardization initiative before establishing a working group and before any participants commit to licensing any IP. An exploratory group is created that is free for any company to join and enables a discussion on whether a standard is truly needed, whether it's the right time to create the standard or whether it's too soon, and whether Kronos is the right organization to define such a standard, or is there a better organization that has better skills suited to the task. And if there is consensus that this would be a worthwhile effort at Kronos, then use cases and requirements are captured in a scope of work document, and that is enabling for a working group to start design under the Kronos standard processes. And Kronos is organized to create a forum for the industry, including many direct competitors, to safely cooperate. Any legal entity is welcome to join Kronos. There is a membership fee, but Kronos invests those fees into building standards in their ecosystems for the benefit of the industry, as we are legally established as a non-profit. And we try to keep those membership fees as low as possible. They start at just $3,500 for small companies, hopefully to prevent those fees from becoming a barrier to participation. All members have access to all discussion and design materials. All meetings and discussions are all fully transparent, with a decision-making process designed to build unanimous consensus wherever possible. All members have one vote, so there is never any one company with outsized influence, and so all design decisions are very typically made on technical merit. And last but not least, all specifications are created under the Kronos IP framework. And actually, the IP framework sometimes causes some confusion, so let me cover that next. So people are familiar with open source projects, and if you use an open source project, you'll be familiar with the concept of looking at the outbound license on a repo that defines your rights and obligations if you decide to use that source code. And similarly, a company using an open standard needs to know what rights and obligations the creators grant you if you decide to implement that specification. And usually the most vital rights to understand, particularly for specifications like Vulkan or OpenXR that are implemented in hardware, are the patent rights, because the use of patents may involve a royalty payment for each device shipped, and that can fundamentally affect whether a company will want to use an open standard at all. So what I'm showing here is what I call a typical traditional IP framework that, in my opinion, has a number of potential problems to make it less than ideal, and has created situations that have probably sown uncertainty and doubt around the terms open, and have even caused patents to be regarded by some as evil. Now, Kronos and many other organizations have more modern IP frameworks than this, but I think it's instructive to understand some of the issues that modern IP frameworks have been designed to avoid. So in a traditional IP framework, companies participating in a standards organization are asked to explicitly list any patents they are aware of or that they own that would need to be licensed, together with licensing terms, especially highlighting any patents whose use involves a royalty payment. Implementers would then need to go and negotiate with individual contributors to get a license for any necessary patents. For example, this is common with video standards such as MPEG that actually ended up creating a patent pool, so implementers didn't have to negotiate royalties with multiple contributors individually. So here, open does mean that any company can contribute and use a specification, but it often does not mean free. And this process creates issues. For example, asking contributors to explicitly list relevant patents is not fail-safe, as patents can be missed, and disclosing patents is generally a bad idea. It puts other companies on notice, leading to potential accusations of willful infringement that can lead to triple damages. And overall, this kind of traditional IP framework is slanted towards enabling companies to charge for their patents rather than creating standards that are genuinely free to deploy. So by contrast, let's look at the Kronos IP framework as an example of what I call a modern IP framework that's used by many standards organizations now. Here, things are turned around, so the focus is on creating standards that enable open participation and uses in the industry and are royalty-free. When companies join Kronos, they broadly agree to grant a royalty-free license to any essential patents they own for any conformant implementation of a Kronos ratified specification. This is fail-safe because it includes all member patents without needing to disclose or discuss them, and that protects everyone involved. The patent license is carefully crafted, so the license grant is as narrow as possible to protect the member's IP, while providing precisely the protection that the standard needs in the industry. So for example, possible implementation techniques not explicitly mentioned in the specification are not licensed. But the key bottom line is that any company implementing a Kronos specification can choose to become a formal adopter, and when their implementation passes the conformance test suite, they can simply participate in a single reciprocal royalty-free license, and they get licenses from the 180 or so Kronos members and all the other adopters. And in this way, patents are transformed from evil into a benefit for adopters. The more patents the Kronos members own, the stronger the protection the reciprocal license provides to shipping implementations. So once an API specification, and here I'm using OpenXR as an example, has been released, how does an implementer become conformant? Kronos invests significantly in creating rigorous conformance test suites for each API that helps to ensure that implementations from multiple companies provide a reliable cross-vendor platform for application portability. Kronos posts the conformance test suite in open source under an Apache 2 license that is free for anyone to use. And Kronos encourages anyone implementing the API to make free use of the tests in their own internal testing. If an implementer wants to become officially conformant, to receive a trademark license to use the name and the logo of the specification on their implementation, and to participate in the Kronos IP license, they can become an adopter. There is typically a small one-time adopters program fee to provide access to the adopters portal to upload test results for working group approval, but the fee covers any number of products and is waived for bona fide open source projects. Then the final stage in creating an open standard is to build its tooling ecosystem. And this is where open source becomes an invaluable tool to enable adoption of open standards. For example, most Kronos working groups host the markdown source of their specifications on GitHub under a Creative Commons by attribution license that enables anyone to freely remix their own versions of the specification, for example, as part of educational materials, and to post pull requests to help fix spec bugs. Then Kronos builds and publishes the canonical PDF and HTML versions of the specification from that markdown source, and they are posted publicly and are available to all at no charge. And in addition to the conformance tests being posted in open source, Kronos develops and posts tools and SDKs and often sample API implementations on GitHub, again, under a permissive Apache 2 license. So that was a super fast guided tour around one standards organization. There are many standards organizations in the industry, and each tends to have a specific area of focus and expertise. When multiple standards organizations are working in related areas, most will seek to work with other organizations to leverage or influence each other's work and to avoid duplication of effort. The types of cooperation could be quite varied, depending on the style of the organizations and their mutual interest. And I've shown just some of the current Kronos liaisons here on the slide as an example. It can be an issue that liaisons between groups tend to be formed on a rather ad hoc basis. It's often limited by lack of industry connections, and standards organizations tending to stay in their own silos through just lack of bandwidth to look over the wall at the bigger picture. And a call out to Christine. Christine has been a significant force for good here in the AR industry by encouraging standards organizations to connect. And I think the metaverse is going to significantly increase the need for more proactive coordination between standardization organizations. And one good example of standardization cooperation is the work between Kronos and the World Wide Web Consortium, or the W3C, on the Webxr standard that has been developed by the W3C. Kronos works closely with the Webxr working group at the W3C so that Webxr can effectively use OpenXR, which is the Kronos native portability API. And that saves Webxr from having to be ported manually to dozens of different proprietary runtimes. And so here, Kronos is fulfilling its role in the industry by providing native access to XR hardware, as well as rendering for both native and web applications through the Vulkan and WebGL APIs. So it's a good example of two organizations working well together. And my last example of cooperation between standards organizations, which kind of introduces another type of standards organization, is ISO IEC JTC1, which is the premier body for IT-related international standards. JTC stands for Joint Technical Committee, and JTC1 standards are approved by multiple national standardization bodies, and so are among the most universally accepted standards globally. Now, JTC1 has a publicly available specification, or PAS, transposition process that enables widely adopted specifications from industry standards organizations to be recognized as international standards. A standards organization must first be approved as a PAS submitter, and then can submit appropriate specifications to JTC1 for approval by participating national bodies, and therefore international recognition. Currently, there are 14 approved JTC1 PAS submitters, and Kronos was the most recent addition. GLTF 2.0 will be Kronos's first PAS submission, and Kronos will maintain both the Kronos and the international standard versions of GLTF. We'll continue to rapidly evolve GLTF, and we'll be making regular PAS submissions with proven GLTF functionality to avoid fragmentation. So that's the end of my slides. In closing, I would urge everyone here that depend on open standards to get involved in their creation. All of the standards that you see here discussed have been created through the passion and the engagement of individuals from companies that understand their benefit to the industry and wider society. So if you see an opportunity to bring the widespread use of augmented reality and the metaverse closer through a well-considered open standardization initiative, now please get involved at the standards organization that specializes in the domain of that problem. The only way to build the metaverse and get AR widely used is going to be to build standards together. Thank you.
Thank you, Neil. That's just a great summation of our situation. We got a good start, and we need to continue and expand this area for people to understand how it benefits them and their customers, whether they're component creators or service providers. They need to be thinking of their strategy so that they can use standards and open source as tools for success. And I see that Muriel has brought her slides up on the screen. So it's time for me to ask Muriel to share with us how the ETSI Industry Specification Group is trying new approaches Thanks, Muriel.
Thank you very much, Christine, for the introduction. Yes, I will start by saying, oh, hold on, can I change slides? Oh, here we go. Okay, I will just say a few words first about ETSI for the people who may not know what ETSI is. So it's a standards developing organizations. It's one of the 3 officially recognized by the European Commission, and it develops globally applicable standards for all sectors of industry and society that make use of information and communication technology. You may know of them through their partnership with 3GPP. They have over 900 members from 65 countries, so there is a chance also that your company may already be a member of ETSI. So within ETSI, we have set up an industry specification group dedicated to augmented reality. And the main objective is to reduce market fragmentation and enable providers to offer components of complete AR solutions. So we believe that the XR ecosystem will be healthier if it has a diverse range of technology providers who can develop parts of a solution. And then these components, these different parts of a solution can be integrated with components developed by other providers to build a complete solution. And this is really what we're trying to do. We're trying to define a framework for the interoperability of AR components, systems, and services. So I will use the work of ISGR as a way to illustrate a slightly different approach to achieving interoperability. But first, I have to have a logo slide. It's not as impressive as the one that that Neil showed us about Kronos a few minutes earlier. But the group is only 4 years old, so it's much younger. We have a diverse membership with academics, research institutes, but also industry leaders who are technology users and telecom companies. So there's a total of 29 members. Okay, so what did the group do first? What we decided to do was to build collectively an understanding of what an AR system does, so that we could then specify a modular reference architecture of an AR system, and I will explain how this helps towards interoperability. So what you see here is an AR system. It is based on a set of hardware and software components as well as data. So you have hardware at the top, software in the middle, and the data describing the real environment and the augmentation at the bottom. Well, quickly, I will walk through the different components of the architecture because this may help. So at the bottom, before you start the AR experience, you need to create the AR scene. And this is what handles the blocks here at the bottom. So the description of the augmentation, the interaction behaviors, also the scenarios defining the different steps of your AR experience. So when you start the AR experience, on the top left, you have the sensors, which capture the real world. Then the information provided by the sensors is processed by the vision engine here in the middle. And you can have processing units to accelerate the processing of the vision engine. Then the result of the 3D reconstruction and world analysis are stored in what we call the world knowledge at the bottom here. That allows to share this knowledge with other AR users. Then the position and the orientation of the AR device are transmitted to the 3D rendering engine here in the middle. And the 3D rendering engine renders the interactive content and transmits the resulting images, sounds, and haptic feedback to the rendering interfaces. And then finally, the user interacts with the AR scene thanks to the interaction interfaces here that will update the state of the AR scene rendered by the 3D rendering engine. And what the clouds in different colors show is whether some of these components can run remotely in the cloud. I will stop there. This understanding of an AR system then led us to define a modular reference architecture with 11 logical functions and about 18 reference points. So the reference points represent the interactions between the functions. So how is that helping with interoperability? Well, first, it defines the logical functions you need to build an AR solution. And more importantly, the interaction between these logical functions. So typically, if you have a standardized interface, so what we call a reference point will be instantiated by an interface in the physical system. So where you have a standardized interface between components of the framework, then this allows you to swap components without affecting its functionality. And this typically prevents vendor lock-in situation, which goes towards having a healthier XR ecosystem. So at the moment, you may feel that some of the reference points here identified are not used or not necessarily useful because a single provider provided two functions. So if that is the case, then obviously you don't need to open that interface. But in the future, it may well be that a provider comes along with a highly specialized component with a much higher performance, and having a standardized interface will allow the technology user to swap an existing component for maybe a higher performant component. So this is really the first step for us towards greater interoperability. So identifying the key functions and the key interaction between these functions of an AR system. So this builds a common terminology also that is useful to map existing standards onto the reference architecture. So we started this exercise and more work needs to be done here. You can see what Neil talked about, the constellation of standards and how they can be mapped to this reference architecture. This also allows us to identify where there may be existing gaps that should be the focus of more standard work. So at the top, well, briefly, I guess, if we start at the top in the hardware function, then you find the world capture here, and you have existing standards such as the Chronos embedded camera or OpenXR. For external communication, there's Etsy doing some work with the group called CIM. There's also MPEG-V. And we could go around the architecture here, around the asset preparation. You have many standards looking at data and 3D models. In the transmission side, then when you start using the network, then you obviously have 3GPP specification and work also from a multi-edge computing group within Etsy. I'm not proposing to spend any more time on that. But it is really to illustrate that there is certainly a lot of standards out there, and they meet some of the requirements that are identified in the interaction between two functions. This is the list is probably not exhaustive, and the work is not complete yet, so that mapping of standards is very much under construction. So as I said, 11 logical functions, 18 reference points, existing standards. So it really doesn't make sense for the ISG within Etsy to try and develop a specification for each of these reference points. So we conducted the survey amongst our members to identify the reference points which members felt were of the highest importance in terms of, or highest benefit in terms of achieving interoperability and of importance to them. So you will find here the reference points that are highlighted here in red between the world capture and the world analysis, and between world analysis, world storage, and world storage and the AR authoring. And the work really focused on the top one between world capture and world analysis, and the bottom one, the world storage and AR authoring, as the one that will bring the highest benefit to the industry. And for the API, for these reference points, we decided to use an implementation-driven standards development approach. Neil also touched on that, how open source development complement the development of a specification. So here, this is an iterative process. You start with an initial specification of the API. You develop open source bricks or components, building blocks, that allows you to test this API. You interface it with existing implementation. So you need to develop wrappers that will emulate the interface between the API and the existing implementation. And you test it, you validate it, you revise the specification if you find that there are still some issues, or in particular in terms of interoperability. So the specification was interpreted one way and it works with implementation 1, but maybe not with implementation 2. So you iterate until you're satisfied that the API is validated and applicable to a number of implementation and enables interoperability. And you end up with a specification which is implementation independent. And that will be published by Etsy. So to emphasize the importance of collaboration and coordination, as you saw on the reference architecture that the ISG has defined, there's a range of expertise that are required, and no single organization could think of developing technical specifications for each of these functions or interfaces. This is a reason to avoid duplication. This is the reason why it is so important to coordinate efforts between standards developing organizations. And Etsy has a number of MOU in place and liaisons with existing, the organizations you see here on these slides. So for example, Kronos, ISO, GTC, IEC. We also have liaisons with what I would call more industry forum, like the area, or XR for All, which is an EU funded project that ended last month, but the activity is continuing through the creation of an association called XR for Europe, and then OpenAI Cloud, and you will have a tutorial from then in the afternoon. So we're getting close to the end of my presentation. With the conclusion, what I wanted to say is that AR is a mature technology, or at least it's no longer an emerging technology. So it disappeared from the Gartner's hype cycle about 2 years ago in 2019. There are fantastic development in spatial computing and edge computing. So this is no longer a barrier. There's certainly a range of commercial solutions. There are open source projects, and we will hear more about it in a few minutes by Christine, with also an overview of the Constellation of Standards that exist out there. And still, the challenges to achieve interoperability remain, and we can still find a number of solutions which offer end-to-end solutions to circumvent this interoperability challenge. So I would say, if you understand now the importance of achieving interoperability, do get involved in standards development. I would encourage you to join the industry specification group ARF within Etsy, and you can find more details here and on the web page of the tutorial as well. So thank you very much for your attention.
Thank you, Muriel, for this excellent introduction to the Etsy, the AR framework, as well as the work that you are doing. So I'll take, I cannot start screen sharing until you release yours. So I think what's fascinating and illustrative is that 2 different standards organizations that you've heard from today have spoken about two important themes. Well, many. Interoperability is their goal. There are standards organizations and there are standards for which interoperability is not the primary goal. And I do want to make that clear, that there are standards that can be used for regulation, for safety and health, and other industry requirements that are outside of interoperability per se. This particular tutorial focuses on the interoperability problems and the interoperability solutions. So the solutions to those obstacles, but I don't want to paint the picture as if this is the only type of standard that exists. Secondly, I hope you've understood that in examples of two, they are open to new ideas, to participation at many different levels. And generally speaking, that is the case for other standards organizations. But as I showed you on one slide, there are standards that are developed in a bit of an exclusive environment. And that doesn't mean that they're bad. It means that they were developed in a different way. So there are many different ways of developing specifications. With this presentation, and for the next 20-something minutes, I'm going to be explaining, introducing to you many other standards, organizations, and specifications, as well as a few open source projects. In these cases, I'm not going to get into very much detail because I've already recorded a video and put it up, and we'll make that accessible from the web page for this tutorial. And it will cover more detail about these. So I want to start by sharing with you the list of standards development organizations and working groups that I personally monitor. And many of these, more than half, I'm not just monitoring and attending the meetings, I'm personally contributing. I'm putting skin in the game. So I do want to make sure that everybody sees that our efforts are not just in words. We are actually putting in our own skin. And furthermore, there are industry associations and communities that are important. You've heard them mention already a few, and there are even more that I monitor and participate in. And the reason is because these systems, these groups may not directly develop the specification under the IP frameworks, but they have an important role in development of use cases and the requirements, and their membership are what I think of as the first line of defense. They should be there reading draft specifications and giving feedback to the working groups. Now, how can all these activities be compared? Well, there isn't one framework or one size fits all. What's very important, in my opinion, is that you as a researcher or an engineer or a company, that you understand your value proposition in augmented reality and where you can add value. And look at those particular activities. Another way of looking at this is going into your organization and seeing which SDOs, standards development organizations, do you already belong to, and you have the rights to monitor, to read the draft specifications, and to make comments and participate from your personal perspective. You can also use a conceptual framework or a reference architecture. There are a few. We showed you already the ETSI AR framework, and I'll be using that in the next slide. I also think it's helpful it helps me when I'm thinking of these activities and how to prioritize my efforts. I think of things that activities and effort that has to be done in advance of the AR experience delivery. It could be milliseconds before, or days and weeks or months before that AR experience delivery. And then I compare that, or I think of those activities differently than the ones that have very, very low latency and that are happening during the AR experience production. So Muriel already introduced to you the framework and this model, and I want to add a few things to it, some segments. I think of these dotted lines here in the following way. The segments, or the functions we call them, and the reference points that are above the dotted lines are primarily during the AR experience delivery, that exact instant in time when the user's context is being acquired and used. And then there are these other functions. They, in some ways, can be done automatically during experience delivery, but they're primarily functions that have a role in the background prior to the delivery of the experience. And then below, at the very bottom of this figure, are functions that are important because we need connectivity, we need security identification, and we need other types of services in addition to what delivers the AR experience. And so I think of these three segments, and I've taken the same figure that Muriel shared with you a few minutes ago with these lines. And so you can see this stratification of the different standards groups. You can also begin to see, and I've added probably 10 more logos to Muriel's slides since I received that. You can also begin to see that there's clusters of activity. In the upper left-hand corner, there's many different groups that are working on the sensors to understand the world, to capture the world, and to deliver different external application support to the scene of the user. So Internet of Things, for example, and geospatial information databases. So you can see a lot of activity in the upper left, and there's also a lot of activity in the lower right-hand corner. So we can see that these areas will require more coordination between the standards development organizations. But by no means do I want to suggest that we're going to go through every single one of these logos in sequence, although I do, but I'm not going to do that for you. If you would like more detailed information about the projects and specifications, you can go to the webpage about this tutorial. There is a standards working group page dedicated to this. And yesterday when I updated it, there were 39. And that's not counting the audio and video and basic transmission. Those are 39 projects that are relevant to augmented reality today. And I'm going to present in the next 15 minutes a quick overview of the different status of different specifications that are the most important. But I encourage you to watch the public video that I recorded yesterday. So one of the groups that's been mentioned several times is the W3C, that's the name of the standards organization. The Immersive Web Working Group is the working group, and the suite of specifications on which the working group is developing is called Webxr. It's not just one Webxr. The first one that was released is the Webxr device API, which allows, it specifies this core feature set so that the application can select the output device, render the 3D scene using APIs as from OpenXR, for example, or elsewhere, and that the scene is delivered at the best possible performance. And it also manages motion vectors that are created using inputs, usually for VR. As you can see, the editor specification is very current. It just was worked on last week. and updated. And so this is an example of where development is happening in the open. And there are other tools and SDKs that are being developed, as Neil described, as companions to the specification. Another one of the specifications that the working group is developing is called AR module. And so there are, the process here is that there's a community group in which anyone can contribute. And then that when the community group is far enough along in developing the requirements and understanding the use cases, then it moves a module, or a piece of the module can move into the standards development process. And the farthest along so far is the depth sensing editors, the depth sensing segment. And you'll find that is also available, as many others in the W3C. But one of the things that's super, super important to everyone working in the W3C and in all aspects of augmented reality is privacy and security. And those remain major issues for our community and for standards. So I'll encourage you to read the explainer on that subject about how this is being dealt with currently and some of the options. In order to be able to generate realism, we need to know what the lighting conditions are and where the planes or objects are in the user's context. So that's the lighting estimation module, and then the level of real world geometry. So these are important for you to take a look at. Another very large and active work in the W3C is happening in the Web of Things, or the WAT working group. They defined, I believe, more than 3 years ago, an architecture that describes a conceptual framework very similar to the conceptual framework that the ETSI ISG produced. But in this case, there's also something called the thing description. And that was another specification. And the thing description is to the IoT what an index HTML is to a website. It's the entry point. And after that, many things are supported. So you can see that the brown shows you where the thing description is referred to, edited, or is used to manage the entity. The Cronus group, about which you've heard a little bit today, is also extremely active and has many programs. I really like the way Neil had shared this cluster, these 4 groups of specifications in which Cronus groups members are working. And the fine red line is around the ones that are probably the most relevant right now, but all of them, whether you're looking at the input or the output, or whether you're using 3ds, are in some way impacting the adoption of interoperable augmented reality. The Embedded Camera API Exploratory Group is approaching the development of its scope of work, or one or more scopes of work. And as we mentioned, the OpenXR is not only under mature development and following the processes that Neil described, it's also getting a high adoption. So we have here an illustration to show how the software or the applications and different layers above OpenXR can all refer to this API. It creates an abstraction layer so that the underlying hardware and enabling components, some of which are implemented in software, can be neutral to the content or the use case above. And this is extremely powerful, and I'm sure you'll be hearing more about it if you have not already. Neil didn't mention a lot about GLTF, but he usually does in his presentations. I like to use his language and say GLTF is to 3D objects what JPEG was to images, or is today to images. You just never have much opportunity to use images in other formats. It is very powerful, providing a transmission format. That's what the TF stands for. And in the last 12 months or so, there have been a lot of extensions published and tools. So again, this is very popular among AR development circles and be increasingly supported in authoring tools. There's much, much more to say, of course, about Cronus Group specifications, but I'd like to turn now to the OGC. The Open Geospatial Consortium has, as you can see, something on the order of 10 specification groups that are active or producing and updating and extending their work. The ones I'm directly involved with on a weekly, monthly basis, and I chair 2 of the working groups on the left-hand side. And then, so I'll tell you just a little bit more about 2 of those. GeoPose was started about 2 years ago. AR is one of the primary use cases, one of 5 use cases. So it spans many other domains, such as drones and autonomous vehicles and robotics, reconstruction, simulation. There's a need for a universal way of expressing position and orientation. And we've developed a very, very robust standard. I want to say that has been developed partially internally until mid-February 2021, where we expose that up on GitHub, and we invite you to go and read the version that's up there in the repository. We also regularly release screen movies with updates. And just last week, the OGC Architecture Board approved the draft specification for public comment. That's a formality. You've had access to it for already 6 months, but we're now very busy developing implementation of the 8 standard targets. So while we say there's one GeoPose, I want to make it clear that within the specification, there are different standards targets for different requirements of development. We're also preparing guides and a website to help developers and reviewers of the specification better understand the fundamental concepts. Another working group that I've been involved in for a very long time is the Points of Interest working group. So what is a point of interest? You may not have heard about it, but it is just very simply a location for which information is available. That information could be simple or it could be complex. It could be an entire building, could be qualified as a point of interest, and it would have multiple languages and lots of accessory information. We're very familiar with getting access to using the web. But there is not today a universal standard for specifying either simple or complex information sets. And so this work was recognized. There was a need for this 10 years ago, and it started in the W3C. We found that it was too confining because the applications and use cases were much, much broader than just what you could use in a browser. It was adopted for a short time by the OGC, and there was not sufficient interest to continue the development. In late 2020, I proposed to dust off the work that we'd started in the W3C and recharter with today's use cases and more modern, shall we say, processes and requirements. So we rechartered that, and for the last 6 months, we've been working together. Now, in this case, we're reviewing what already had been done, and we're revising and updating the requirements, but we're also trying a new approach, and that's called model-based standards development, in which you create a model, a symbol, a machine-readable symbolic language of the specification of what it's supposed to do. And then you can produce encodings in many languages, and you can apply the model to many different use cases as long as they meet the requirements. So it's another variation on the theme. You heard about the background of the ETSI ISG AR framework. The current status is that for about 1 year, we worked together quite actively on the development of requirements, interoperability requirements around world storage, the low left-hand corner of this figure. There were 4 reference points on which we focused to understand what's necessary for world storage, world analysis, to work. And the beauty of this is that we also found that the systems are unstudied, very low level of awareness about this world storage, world representation. So the specification is very, very valuable, and it was published in the summer of 2021. Since about January 2021, I was a rapporteur for another specification, world capture, world analysis, and scene management requirements. That's what you see in the upper left-hand corner. As you've heard me say a few minutes ago, this is a very crowded area. We wanted to know exactly what are the requirements for AR world capture, not for a generic, an autonomous vehicle world capture or other system, but what does an augmented reality system need? And then we were able to hone in on those and examine, I believe there were 18 standards in that zone that we looked at, and we'll be developing relationships and asking for their inputs. Maybe they're going to extend their existing standards. Maybe they're going to find a new profile of their standard just for AR. So the ISG approved this draft specification, and we're in the process of editing before release later this month. I could go on, and I will, for just a few more groups. The ISO-IEC is one of the international standardization groups that Neil spoke about. It has relationships with other standards organizations, but also develops within its own internal working groups new specifications. The working group 9 focuses on AR continuum concepts and reference model. That's work that we started doing, I want to say 8-9 years ago. And that group is still working. And this is just a snapshot of 3 of the documents currently being edited. There are closer to 5 or 6, I believe. 3GPP was also mentioned earlier. Generally, this is a standards body been working, it's a partnership of standards organizations that's been working in telecommunications, but they knew that augmented reality is one of the drivers, the use cases for 5G. And so in 2018, began developing a technical report, 26928, about XR requirements. And they defined an architecture where XR would fit into a 5G system. And this work has continued. A new report, the TR 998, the 26998, focuses on glasses, 5G AR glasses, and the requirements for those and the architectures for those. So very detailed, very important work that will impact us all. Also, there's the IEEE has many standards organizations specifically looking at augmented reality, but I just want to highlight this one that started in 2021. So it's a fresh new working group on focusing on the spatial web. Spatial web, you might have heard of, is something analogous to the metaverse. It's not necessary for us to quibble about the high level labels that we put on things. The reason this is very important is because the spatial web needs a protocol, an architecture, as well as governance systems for credentialing and certifying and contracting in an automatic way between entities in the spatial web. So this standard is very broad. It will cover at least these 4 points that were defined in the project at launch. And it's now meeting monthly, and you'll be hearing more about it in the near future. This is also a relatively new or fresh IEEE working group, focusing only on AR and mobile devices. So no projection augmented reality is not in scope, but the other forms of augmented reality displays are. And this also took a bit of an abstract, started abstract, and then drilled down into requirements. So they defined functional requirements, technical requirements, performance requirements, and the testing methods. You may not have noticed, but Neil spent a lot of time, or he shared with you how compliance is an important part of specifying interoperability standards. And the reason is because you don't know if you support that specification if you don't have a method to test and to certify your compliance. So I encourage you to look at this. Very, very interesting example of a community basically creating its own specifications. Another that is, this is more of a compliance regulatory standard and less of an interoperability, but it could be an interoperability standard one day if the component manufacturers agree to adopt it. This is a Underwriters Lab does a lot of safety protocols. And so in 2019, there was a new group started, an experts group that is mainly composed of those display manufacturers, very, very high level of participation. And their concerns are with the safety of the equipment that they build and they sell. And what's exciting with this is that they didn't start with a blank piece of paper. They leveraged the existing requirements of a prior UL specification that was designed to control or to reduce risk of electrical and fire hazards in AV equipment and IT equipment. So it's really interesting to see how you can start with an existing specification and build on top of that. Now, just a couple of examples of open source projects. These are, in fact, just a few examples. And if you dig a little bit further, and perhaps if you are an ISMAR attendee for the past few years, you'll have heard and participated in tutorials and workshops of other specifications, other open source projects. This is a new one. It's based off the IEEE AR learning experience model. IEEE 1859 or 1589, that's not the right number on that, but they use the concepts of web of things. Gee, where have we heard that recently? So they created and defined the web of augmented things. And this is all being done in the open and on the GitHub repository where you can get sample code and the SDK. Another open source project. And by the way, all these open source projects, I've collected some videos. They're available on the YouTube platform, but I'll be embedding links to these in the tutorial website. So another project that has been maturing for several years, I believe it started in 2018 or 2019, is SOLAR. So the purpose of it is to provide computer vision pipelines targeting just augmented reality applications. It provides the interfaces, computer vision components from third parties and plugins such as for Unity. So I highly encourage you to take a look at the SOLAR. I believe the most recent release on the repository was in August of 2021. So it's active, and I'd like to see if people have feedback and are implementing this. Finally, this is another open source project that is kind of a hybrid. In other words, it's an open source project, but it's also a specification. So it's not just code and running code, it's also a description of common language to describe geospatial information. Gee, why would that not be the Open Geospatial Consortium? Well, it's tightly connected to the Open Geospatial Consortium, and I expect that there will be increasing activity. In fact, the chief architect on the spatiotemporal asset catalog specification is now staff at OGC. Gee, what a surprise. But we in augmented reality need to be able to discover collections of data that are relevant to us in a consistent way. And so this may be one of the tools we use in the future. Again, please don't hesitate to go to the tutorials website. I put it in the link in the Discord channel, and I'll put all of the URLs that I've shared here today into the Discord channel for this tutorial. I encourage you to watch the recorded video for more information. Thank you very much. And I believe now that I have stopped sharing, I will be able to invite our last speaker, Bill Bernstein to present kind of a case study of how all these things come together and his professional experience. Thanks, Bill. I see your slides perfectly.
Great. First of all, I'd just like to thank Christine for this really great opportunity to share my work over the past few years. My name is Bill Bernstein. I recently joined the Air Force Research Lab and United States Air Force Research Lab in Wright-Patterson Air Force Base right outside Dayton, Ohio. I mentioned at the top of this tutorial that this work has mostly been done during my 6-year stay at NIST, or the National Institute of Standards and Technology. And I just wanted to mention that a lot of times NIST gets confused with some of these other standards development organizations, yet NIST is really more of a curator of standards activities. And when I was my time at NIST, we sat on a lot of standards bodies to voice a neutral opinion for the greater industrial base of the United States. And my talk today will focus on how we can leverage a lot of the great work that's been shown in the past 3 presentations to address a particular application domain, and that is manufacturing. So when I think of interoperability, not only do of course, it's important to deal with interoperability within augmented reality systems and architectures, yet there's another interoperability problem or an expanded interoperability issue or challenge to use those same tools within a particular application domain. So once you deal with the domain-specific models and domain-specific data, the problem explodes even greater. So to begin, I wanted to give a brief introduction to this notion of Industry 4.0. And Industry 4.0 was originally termed in Germany, and it's the notion of combining advanced manufacturing services with digital infrastructure. The reason why they coined it 4.0 industry is because it represents a 4th industrial revolution, where the ubiquity of digitalization and computerized systems has really creeped into every aspect of our lives, including manufacturing services. You might also hear the term smart manufacturing, and that's a term coined in the US. To me, and this is in my personal opinion, they are synonymous terms and we can use them interchangeably. And you'll notice that when you look up Industry 4.0 in Wikipedia, for instance, you'll see these key terms as in interconnectivity, information transparency, decentralized decision-making. All of these kinds of attributes of smart manufacturing Industry 4.0 require a great deal of interoperability. And I've listed some examples of both advanced manufacturing services and digital infrastructure. And if you search Industry 4.0 on Google Scholar, for instance, and see some of the academic work that is around this topic, you'll notice a lot of these cross points between the left and the right, what you see on your screen. So for instance, when we think of advanced manufacturing, additive manufacturing, for instance, comes to mind quite often, smart materials, flexible electronics, which have really exploded in the past few years. And of course, robotics is always around those different technologies. And the specific digital infrastructure that comes to mind are things like image recognition and the greater concepts of artificial intelligence, cloud computing, knowledge management, knowledge graphs, and ontologies, and of course, extended reality, including augmented reality. So when we try to think about using extended reality, or in this case, augmented reality in an industrial setting, and this slide is based off a conversation I had with Christine, I think maybe 3 years ago. We can kind of bucket how people view the different functions across usable industrial AR workflow. On the left, you see one very important scheme in how we represent the world itself, the physical world in the digital world. So how do we capture what's happening in front of the user and explicitly characterize that on a computer in a machine readable way? And on the right, once we're ready, we want to present that information, of course, in the most usable way possible. We've seen a lot of talks at ISMAR, especially last year, focusing on embodiment and presence. These are the kinds of things that people take into account on how you render the digital information properly and onto which specific presentation system based off of your needs. There have been standards that we've heard about the past hour that address both boxes here. But in manufacturing or in other industrial settings, once you link these standards or technologies to the underlying data, it becomes very, very challenging. So in the blue box, I've listed a few attributes of what we call these domain-specific models. These could describe devices, or in manufacturing, those could be machines. They could be people, operators on the machines, or even managers. Spaces and manufacturing, this gets pretty complex, whether it be a large production field or even modeling a supply chain, for instance. Plans is a very broad term that could relate to the plans of how you're building a part, but then could also be the plans of how people are interacting in the space. And of course, materials, whether it be inflow into the production plant or outflow as products. And linking these domain-specific models to how we represent the physical world or how we present it to the user on the right has mostly been completed by in-house teams that are very well versed, developers very well versed in AR. And the vision for how we can approach a more interoperable workflow would, I'm not saying eliminate these teams, but have better communication across those that really understand the gray boxes and those that have been trained deeply, like me, in the blue box. And if we achieve this vision, there will be less rework on the AR scenes themselves. I was just talking to a collaborator of mine where they have to retool every animation for an assembly if one small part has been changed. And that is because the error associated with showcasing a AR assisted assembly is very prone to error. So it's just one simple example. So what my group's work in the past 6 years has been focused on, or I should say past 3 years, has really been looking at these dotted lines and how we can show how using different standards within the manufacturing world and within the AR community can help expedite this workflow. So I'll just give a sampling of some of the Industry 4.0 specific standards. There are many, many. I don't know whether AR has more than Industry 4.0, but I think they probably rival one another. So a lot of these efforts are focused on constructing information models to store the data properly. Some of them are focused and have been focused on presenting annotations, and I'll show an example of that, onto some of the traditional 3D CAD systems. ASME has a popular standard for that. Others are really focused on communication from machine to machine within a production plant, for instance, timestamp protocols, messaging, etc. You see OPC UA is very popular across the industrial base. MT Connect is an emerging standard for time-based protocol of what's happening on a controller of each machine, and so on and so forth. But the issue, again, and this also speaks to interoperability, is even within Industry 4.0, interoperability is a big keyword, that harmonizing across these different kinds of standards, because there are people underlying these different committees. How do we do that at scale? How do we deal with the semantic interoperability, how people call or name different attributes in different ways? Similarly, and I could not do as well as my counterparts here, there are many AR standards activities. And when you link the Industrial 4.0 standards that I just briefly mentioned on the previous slide, again, it's a big challenge on how we harmonize within AR, but then also across to the domain-specific models that exemplify Industry 4.0, and specifically at scale. So this is a pretty large topic that has piqued some interest. For instance, you might see a few posters at ISMAR that try to speak to these notions. I saw a few last year, for example. So now I'd like to give two examples that came out of my work at NIST. And if you have any questions about the jargon or the manufacturing specific information, I'd be happy to talk offline on Discord, or you can type them in the chat and I can address them briefly in the panel. So the first example is, how do we leverage standards to show design and inspection data for a product in AR? So of course, people have been able to achieve this in one-off prototypes, but again, the idea is, how do we do this at scale? And my argument is using standards will help achieve that. So let's look at a typical engineering drawing. And this is a test case coming from NIST. And it's not necessarily a real part, but they use this digital part for standards conformance. And this part is represented in a very popular standard in the engineering community called STEP. And the annotations around it in blue that you see conform to another very popular standard, ASME Y14 series. And I wanted to try to use a term that maybe some of the call might not be familiar with, and that's called PMI. And PMI refers to product manufacturing information. And there are very specific ways on how you must represent PMI, which includes things like how fine grain or tolerance a particular feature on a part must be produced. And the finishing specifications, the physical finishing of surfaces on the part. All these are very, very critical for once a design company sends out a specification to a production plant, that they're getting what they paid for, essentially. And STEP has been around for, I think at this point, 3 decades, and has really helped kind of stamp out how we can exchange this information in a standard way. And to give a brief example, if there are many different commercial CAD systems. I think all commercial CAD systems can essentially read in STEP and write STEP. This is an example from one of my past colleagues at NIST, where they ran some conformance testing against whether CATIA and X, et cetera, can read in STEP appropriately. And we actually reported on specific errors in these different softwares, making sure that, for instance, the PMI is presented well. And you can see across these 4 different screenshots on these 4 different software that the PMI, for the most part, is shown in the standard way, conforming to ASME Y14. And we'll talk about, is this good enough for AR? And my argument is probably not. But the only way to understand if the way you're presenting this data is good enough in AR is to test it. Secondly, I'll also be mentioning another very much emerging standard. It's a pretty large of a beast of a standard, and the idea of QIF, or Quality Information Framework. It's developed by the DMSC, Digital Metrology Standards Consortium, in a consensus basis. And the purpose of QIF is to store inspection data, and this can be quite significant, especially if your product or product system is complex. And here's just a very, very, very simple example of how they store inspection plans and inspection results of measuring a hole's diameter and a hole's distance between what's called a datum, or a reference point for which you're measuring. Again, QIF uses ASME Y14 as its presentation architecture, and how you present PMI within QIF. And I'll just briefly mention that QIF has been now become an ISO standard, and the standard number is there is 23952 if you're interested. Okay, so what we did at NIST was we developed a pipeline, and I'll briefly mention some of that, the attributes or the characteristics of that pipeline. But what we wanted to test was, okay, we have these collection of test parts in STEP, and can we leverage the standards in the smart manufacturing world to present them on a AR system? And the question was asked, okay, what kinds of opportunities lie in the standards community within AR that through demonstration in manufacturing and design that we could present to those communities as challenges. So we were successful in basically developing this pipeline where we're not really doing much other than reading in the standards data into Unity and presenting it according to the manufacturing standards. And I got to be honest, this is a pretty simple, straightforward engineering project, yet there, shockingly, it had never been done. So you can check out the work will be published very soon onto GitHub once it gets internal approval. But given this pipeline, if you have any step model, you can import it into Unity and present this scene using whatever tracking library meets the needs of your particular product. So really briefly, we read in, and again, apologies for some of this jargon, but if people are familiar with STEP, this might be helpful. We read in a STEP instance file. We then throw it through a NIST product, open product called the STEP File Analyzer, and translate it to X3D. The reason why we translated to X3D was because the STEP File Analyzer already had a translation mechanism. Of course, translating to something like Gltf might be more beneficial for more complex parts and animations. We then build an X3D file that we're able to read into Unity here and construct each one of these annotations as lines and face sets. And using the standard, because you don't expect the information model to change unless there's some changes in the standard, we can build an import script into Unity that allows this translation to work at scale. So here's just a simple video of showing how we're reading in QIF data, so inspection data, where you see the yellow annotation show that there's mixed results in how well a batch of parts met specification. Red means that there were failures across all parts, meaning that it did not meet its design requirements, and green means it passes. So the idea is that using this pipeline, we can get to the information within AR without getting off of it. Okay, so the second example I think speaks a little bit better to what we're here for, and that is to show how we can find opportunities in leveraging standards from both communities, meaning a standard from the Industry 4.0 community and a standard from the AR community. And this is, again, a fairly simple project, but the idea is sound in that it shows how if you build your data within these standard frameworks, you can use them as tools for building these pipelines more amenable to high scale. So in this example, we're going to show how do we spatially orient manufacturing equipment that is streaming data in an industrial IoT sense. So the standards that we used were, one was from the Open Geospatial Consortium called Indoor GML, which is a fairly mature standard, which describes indoor spaces. It has a simple XML format, and it can provide semantic and geometric representations of these indoor spaces, including waypoints and transitions. So it kind of can specify or characterize how you should move through an indoor space. And the standard that we wanted to harmonize with or connect with is MT-Connect. And MT-Connect provides a semantic vocabulary for manufacturing equipment. So as an example, if you have a CNC or a computer numerical control milling machine, as you see in the, see a graphic there in the slide, it outputs lots of data on the movement of that tool. And for instance, how fast it's spinning, where it's moving, etc., whether like hydraulic pumps are on. So what MT-Connect does is basically provide a standard way of timestamping all that data and stream to a central server so that you can, for instance, develop dashboards and understand what the machine is doing at any given point in time. So a lot of people are using this right now. You can even use it in concert with something like OPC UA that I mentioned briefly, another very, very popular Industry 4.0 standard. So at NIST, we had a test bed where we had about 11 machines connected together on MT Connect, streaming to a public service. You can find it at smstestbed.com. And what we did was we created a very simple model, indoor GML model of that space, and just showed how, given that you have an indoor GML representation of the manufacturing space, and you have MT Connect streams coming off each one of those machines, we basically developed some scripts that read one to the other, and we can construct these virtual scenes very, very quickly, given that the foundational representations adhere to the standards. So rather than fixing the application side, you're more so just debugging how you're constructing the representations and making sure that they conform to the specifications of the standards. So similar to the red, green, blue, red, green, yellow color scheme from the previous example, we show that red machines that you see on the screen are in use, green are available, and for whatever reason, yellow are not streaming data. And here's just a very simple example on how you could use this for some kind of planning. So you can imagine an operator who must perform maintenance on different machines. So using the same indoor GML representations, we had a student who developed a very simple tablet app that basically provides the shortest path from one waypoint to another, knowing the transitions and the safe paths within a manufacturing floor. So the idea here was that if an operator, kind of like a traveling salesman approach, needed to go to different machines, they would get a sense of the best paths forward. And of course, you can, because everything is based off standards, you can grab specification information about particular machines. We didn't test this on real operators, but it was kind of showcasing what you get for free, so to speak, if you connect the two standards together. Okay, so I hope those two examples were useful. Be happy to talk about more broadly how AR is benefiting Industry 4.0 perspectives, because it really is. There's been some great gains. And I had four big kind of takeaways, big picture takeaways of my experience using standards as tools for industrial AR. And that is that we really need more flexibility in these industrial AR implementations and installations. If you go to a lot of the folks that are using these in practice, you'll notice that many of their installations are in fact one-off prototypes, and that any particular changes, whether it be to the animations of the assemblies or even the data itself, is quite buggy, and changing anything kind of breaks what they had before. So they're more of read only rather than edit and go. Secondly, I really believe, and I think we've demonstrated that to some extent, that standards can be used as tools to provide that flexibility. If you're dealing with these issues early within the representation space, rather than the interaction presentation perspective of the user, a lot of these problems can be solved quite easily, or I should say more simply, because once bugs start happening and the users get very frustrated very quickly, especially if they lose sight of where they are and it does not conform to their normal work practice. So that's quite important. Thirdly, working across standards, whether they be within XR or across to application domains like manufacturing, does uncover value in the form of interoperability. I mentioned that it also provides value in flexibility and adaptability. And lastly, and this is fairly obvious, but there's a lot that's out there. And I think Muriel, Neil, and Christine mentioned about cross collaboration within the XR standards community. I think the same must be done in my application domain, that is in manufacturing. It seems like there's a lot of rework of concepts that have already been covered by the XR community for those that are trying to use AR or leverage AR in manufacturing use cases. I would spend a good amount of time upfront in understanding what's already out there at the core technologies that represent the AR ecosystem. And that's what I intend to do to help the Air Force move forward with their manufacturing needs. And it's really cool to be a part of AFRL, wherein the Air Force was one of the early adopters of AR in the cockpit, which is you can go back and see some of the advancements they made, even I think as early as the 1960s. So with that, I'd be happy to take questions within the panel. And again, thank you for the invitation.
Thank you, Bill. Great way to end it, and great way to get down to practical, the practicality of how do you implement all this. And just we don't want to lose sight of the requirements of those end users. And I also wanted to thank you for sharing what you're going to be doing at the what you're doing at the Air Force, a little bit of what you're doing there, not too much, but just that's my first question to you is, how are you going to apply what you've learned in your time at NIST and those examples that you gave in manufacturing in your new role? It reminds me, Boeing invented the term augmented reality 40 something years ago. Cockpits, that wasn't what Boeing had in mind. They were doing a wireframe, the instructions for how to assemble an airplane. But what do you think you're going to be? Can you share with us anything that's exciting or that you particularly are going to work on? You have a job opening, I hear?
Well, I want to be clear. I do not have a job opening, but a contractor that works closely with AFRL has posted a job for an AR/VR developer. I've placed that on Discord, and if you have any questions about it, I'd be happy to answer. So yeah, thanks for the question, Christine. I'm really excited to be a part of AFRL. I will just mention that a lot of what the Air Force is interested in is inspection of field failures. Because when something flying fails, it can be devastating on multiple fronts. So there's a heavy focus at AFRL on material science and inspection at multi-scale, whether it be at even nanoscale up to whole factory level inspection to make sure that these processes are done properly. And AR assisted inspection is a major focus of my, what I expect to be a major focus of my first couple of years here. And the types of capabilities that AFRL and the Air Force broadly have in terms of gathering really incredible inspection data, I think is going to make that really fascinating. So the question would be, where does AR fit in? And quite frankly, we don't know too exactly how it does yet. We have ideas. And we're always looking to talk to other innovators that might have their own concepts.
I have two quick remarks and replies to you. The AR for Enterprise Alliance, which NIST is a part of, and you know that I was active and still am in this organization. We're in the process of choosing the research project that the Area Research Committee will focus on next. The 10th of these research projects to be done under the auspices of the Research Committee. And one of the 5 topics that's proposed is AR for inspection for quality and compliance. So very interesting synergy there. And I hope that the AFRL will be able to join and participate and contribute, if not lead the project. Anyway, I wonder if, Neil, do you have a question for Bill?
Actually, I did have a question, Bill. We haven't talked about this before, so I hope it's not out of left field. The digital twins, I mean, it is kind of another convergence point between manufacturing factories and augmented reality and digital infrastructure. Is that part of Industry 4.0, or is that Industry 5.0? I mean, how do you see those digital twins and what you're working on intersecting?
Yeah, so thanks. I'll just say that, yeah, there's already people saying Industry 5.0, 4.5, but I think, yeah, it all fits into the concepts and the idea of Industry 4.0. Digital twinning is incredibly important for especially aircraft engineering, and there's a significant efforts that I've seen both at NIST and already here at AFRL that's focusing on it. I think what's most, and I think this also speaks to Christine's response to what I originally said in my first response, is that if we have a properly constructed digital twin, we can uncover information on site that is frankly not possible to convey properly in the past. And what I mean by that is if we're able to understand, let's say, failures within specimens taken from the field and then relay that back to on-site maintenance workers or operators, I think that would be a great use case for digital twinning. I also think that there's a lot of complexities and challenges in, let's just say, how to deal with so much data so quickly if you're going to digital twin, for instance, a large production system. And I know that there's significant standards community work being done. There's an ISO, I'm sorry, I don't remember the top of my head what number it is. There's an ISO digital twin framework. There's also the digital twin consortium as part of the object management group. And a lot of people have been talking about what actually defines a digital twin. How often do you need to update data on individual physical things within the virtual space to still call yourself a digital twin? And there's actually quite a lot of disagreement on just that. So some people think that if you just have a model, a digital model of something, then you already have your digital twin. You don't necessarily need to update data related to it. I think I'm on the opposite side of that, where I don't think it's valuable to call a model digital twin. It's really important to keep the communication alive across between the virtual and digital world to really benefit from this new concept. So I hope that answers your question. But yeah, Neil, love to talk to you offline about where Kronos or NVIDIA may largely be interested in that work.
Yeah.
Reminds me a little bit, Bill and Neil, about Newport News Shipbuilding, one of the founding members of the AR for Enterprise Alliance, in which they were required by Congress, if I'm not mistaken, to provide an exact 3D model of the aircraft carriers that they built. It's basically a city. An aircraft carrier is a floating city, nuclear powered floating cities, and they have to deliver an exact 3D model, and that model is changing all the time. It's, as you said, Bill, there, it's a dynamic living object, and this really accelerated their ability or their need for augmented reality, as long as 6, 7, 8 years ago. And I think that it's really important to understand not every use case requires all the features. Tourism is obviously going to be at a neighborhood scale, or maybe it's just the inside of a museum. So there are many different scales, and they'll have to adapt to the different, so those are different requirements.
Yep.
Okay, so I wanted to maybe ask Neil a question. As standards evolve, generations of standards, version 1, 2, 3, and so forth, does that run a risk of creating fragmentation? If products are compliant with version 1 but not version 3, et cetera, et cetera. How does that work?
That's a good question. And evolving new functionality for any standard is always an art form to keep the functionality moving forward whilst not disenfranchising the older versions and the users using older versions. So there's normally a lot of careful design that goes into if it's not direct backwards compatibility, to have easily deployed fallbacks. So and we at Kronos we use the semantic numbering scheme. So if you go from a 2.0 to 2.1, you're basically guaranteeing backwards compatibility. If there are some breaks, then you would go to like a Gltf 3, hypothetically, at some point. But if at some point we need to do that, we would definitely make sure that all the existing content wouldn't break and the existing viewers and applications wouldn't break, and people would be able to move forward in a controlled, incremental way. But it does take a lot of care, because if you don't do that right, you can really damage your ecosystem. So it's a lot of thought.
It reminds me a little bit of even the transitions between domain-specific standards going to more general standards, or as you gave an example, how a specification might be developed with the expertise of engineers in graphics or acceleration, and then need to move that into an international standards organization like ISO. Can you talk about that process, the issues? Do you have to rewrite any part of your specifications before they are ISO ready?
Very interesting question. Yeah. And we're going through our first PAS submission with JTC1. So we're living the dream right now, literally. So our first submission is Gltf 2.0, and we have found there's no technical changes. We are going to do a small patch update, so 2.0.1. Will probably be the version of the specification that we actually submit next week. But there's no technical breaking changes. It's all clarifications, drafting improvements to bring the GLTS specification up to the drafting standards that is needed for a full international standard. But actually, and it does create another versioning challenge, because now you have, if we're successful, and of course, we need to, there's a whole decision process at JTC1. We may not be successful, but if we are, we will have an international standard version of GLTF as well as the Kronos version of GLTF. And as we were starting this whole process a couple of years ago, there was a lot of debate on how we would manage that, because if you have two different versions of the spec, that can be very damaging to an ecosystem too. So, but in the end, we've been very impressed by the PAS process at JTC1. I think they've obviously thought about this, and they give the choice to the standards developing organization, Kronos in this example. We can choose to be the maintainers for both versions. So we're not handing GLTF to ISO and they will do random things with it, and then we can't diverge from the Kronos version. Kronos will be managing both versions with the help and input from JTC1 and the national bodies there. But any changes that come back, we can manage how to fold those changes both into the Kronos version and the international standard version in a controlled way. So we don't get divergence, and Kronos can continue to evolve GLTF at our industry rate. And when we have proven technology that is widely adopted in the industry standard, we can do another PAS submission to bring it over into the international standard. So the Kronos version is always compatible with the international standards version, but is pathfinding out ahead, and then we can fold those changes back into the international standard. So yeah, again, we've been impressed by the PAS process and the degree of control that it provides an industry standards organization, to work in a proactive and constructive way with the international standards community.
Yeah, I know of other examples, Bill, Neil. The one that I'm currently working with is the IEEE Standards Association, working at the very beginning with the Spatial Web Foundation. So a nonprofit industry organization who's dedicated to the development of the ecosystem for the spatial web has a special licensing and responsibility agreement with the IEEE to keep the copyrights clear, and to keep the intellectual property unencumbered, and so on and so forth. So there are many different paths in these domains.
Mm-hmm.
So I wonder, I think Bill asked a good question in our chat. It would be great to hear from our panel what you would like the academic research community to do. What is their role in all of this? I have to say, I have a lot of contact with researchers in standards bodies, in standards bodies today, and it tends to be theoretical, and people are not able to implement enough of what they propose to be able to really test it. And is there any advice, or is there another role we could discuss for researchers in interoperability?
Bill, do you want to go? I saw you on mute.
Sure, take it away, Neil.
Well, I was going to say to the researchers out there, firstly, don't stop. We need you to do research because you are the true pathfinders. But if for a standards organization like Kronos, and as we've already talked, there are many different types. But if you're asking what Kronos would dearly love to interact with academia, we don't want to do R&D by committee. So your cutting edge research, which is still in discovery mode, don't bring that to a standards organization like Kronos that's trying to define specifications that can get immediately adopted by the industry, because it's too early in the pipeline. Again, it's super valuable, but not for what we're trying to do. But if you are in a position where, with your insights, you're discovering that topics that were the subject of true research a few years ago are now becoming proven, and you have that, you can give us early warning that transition is about to happen or is happening, and then suddenly that becomes an opportunity for everyone to bring that into an interoperability standard. So we love to get those insights and those early warnings that new technology is becoming proven and suitable for inclusion in an interoperability standard.
Maybe I could say a few words as well, Christine, about the touch point between research work and standards development. I think it very much depends on the type of standards, because for core technology like compression standards, then it goes hand in hand with the research work, because the researchers work on developing algorithms that will improve the compression rate or the quality of the images. And there you even get a call for technology to reach a specification, technical specifications, where the latest development in terms of what can be achieved by the processing power and the algorithm is reached. So there are, depending on the type of standards, I think for core technology, the researcher works hand in hand with the standards development. I think an area also that we haven't talked about much, and I'm not sure I can contribute that much, but for AR is also holography. There's a lot of work happening there, both in terms of research and innovation, and in terms of standards development in ISO, IEC, JTC1.
That's a really good point to raise, Muriel. And I think that another area that is delicate, I should say, in which there needs to be much more research, but I'm hesitant to suggest that it belongs in standardization, is around user experience and user interactions. Those are domains in which we hope there'll be much more research.
I'd also like to add two things to this question. First of all, if you're working on standards within your project already, this might sound like a silly request, but show it in the keywords. So I think a big problem right now is people are having a hard time finding what's been done with certain standard frameworks. I know that Christine and I found that to be difficult to find in a separate research project that we collaborated on. And secondly, I'm inspired, or was inspired, by a 2020 keynote by Ramesh Rakkar of MIT Media Lab, who did, it was a great talk, and I think you can find it on YouTube, where he made the argument, and I agree with it, especially coming from the manufacturing community, that what folks like me are looking for is, rather than photorealism, more functional realism. Especially when you're displaying data like an AR, it's not as important, well, at least from my perspective, to try to make things look like you would see them. Rather, we want them to be in the right place, showing the right thing. And I think I'm not sure how that relates to interoperability. It might, but I just wanted to make that point.
All right, thank you. I think it's a great topic. We touched, Neil, on GLTF, different versions of different standards, and if that creates fragmentation. What's on the roadmap for AR in GLTF? I mean, are we going to see new extensions, or is there going to be a branch point? What are your thoughts?
Yeah, I think we're about to really trying to figure out what we need to do specifically for AR, as opposed to just being a general asset format. And it kind of actually relates to what Bill was just talking about behaviors. I'm going to use the M word again, the metaverse, but just having multiple products, and you want to have 3D assets that are interoperable at the behavioral level, not just the visual level, I think is going to be a key step in interoperable asset formats. And we certainly want GLTF to be one of those. It's not a branch point. I think you can build it on to what GLTF already has. Some of it may be just metadata, and some broad agreement as to how that metadata is going to be defined and used. But if we don't make this step from having file formats like GLTF just defining the geometry and the textures and the materials and animations, but also things like scale, physical attributes, so you can feed those attributes into a physical simulation. If you're one of your environments that you're taking your assets into, does that. If we don't make that step, then we're not going to get the metaverse. We're just going to get more 3D viewers. Whereas in fact, the idea of a metaverse is that it's interoperable on many different levels, and including taking composable objects and scenes between different vendors and between different engines on different products, on different platforms. So I think that that is going to be a really important step, that probably one of the most important things that Gltf will be working on over the next year or so.
That's very exciting. I think we're going to see a lot of the specifications that were developed before augmented reality was realistic. A lot of those specifications, we could think of them as sort of these precursors when people were thinking primarily about virtual worlds and simulations. One of the examples of that is an ISO specification was developed in the CEDRIS project, SEDRIS, very, very massive specification, became ISO 18026 in 2006. It was updated in 2009. And I'm excited to share that those architects have come back now in 2021, reassembling an old team, trying to find the requirements and measure how they're going to take this monumental specification that is widely implemented in the US Department of Defense, but that's the only place that I know of that uses it. You know, that's great for Bill, but the rest of us better find something a little lighter and tighter. You know, there is there's a role for re-examining good work in the past, especially when you have a very large, well-funded community, right? Like the DoD.
Yeah, absolutely. Don't invent the wheel if you possibly can help it.
Right. And I think sometimes what I see our role as being, this panel and our peers, is to make sure that the word does get out to those standards organizations that are just beginning to think about AR, that, hey, it's great, we welcome them and we want them to participate, but don't ignore or take into account what already exists. And I think we should talk about what we want to see at ISMAR 2022. From my personal perspective, I'm happy to have a longer list on the page of specifications, as to the extent that we can identify the new value proposition, the new innovation that a specification is enabling. What would you like to see, Bill, for ISMAR 2022? What are you going to present next year?
Well, I won't lock myself in to answering that question. Not that I can't share, but I won't for my personal protection, I guess. Yeah, I'd like to see, and maybe there is in this program, I haven't looked at it so carefully, a track specifically dedicated to bridging the gap between the underlying technologies of augmented mixed reality with the application space. I've noticed that usually these are, I don't want to use a strong word, I can't think of another word, demoted, so to speak, to poster sessions, which I've found in the past, my interactions with ISMAR, that I found the most kind of like quick conversations that are relevant to my line of work at the poster sessions. I'd like to see those get a little bit more attention and elevation, because those problems really address what practitioners are facing. We're dealing with a lot of issues at the interfaces, connecting data with let's just say archaic, very traditional systems with this new influence of AR. I think it's actually quite a significant research problem.
I want to say that from the AR for Enterprise Alliance perspective, we've kind of taken a strategy that we don't want to go to the AR events or the AR communities. We want to take our AR community into those industry events or industries. aviation, aerospace, yeah, you list them, energy and smart cities and so forth, to find out, to be current on their requirements, to be better able to understand the use cases and the requirements, which I believe is really where standardists have to start with. You have to define a problem before you try to solve it. Sorry, that wasn't a question. That was a rallying cry. That was like, don't solve it if you can't say it's a problem. Don't try to. But so I think this has been a very, very good panel, and I wonder if there's any last suggestions or calls to action that we can make. I'll start by saying, if people are not yet paying attention to interoperability, it is in your future, whether you want it to be or not, whether down at the most basic component level, all the way up to the user interfaces and applications. Interoperability is a topic that you do need to pay attention to. Bill, do you have a party last thought? I saw, I don't know, Neil or Bill, it doesn't matter, but go ahead.
I am muted first, and I can go first, and then Bill can, and Muriel. It goes back to what I was saying in my presentation. A call out to you personally, Christine. I think you have been, I think, one of the prime drivers in the AR community to getting the various standards organizations to talk to each other, and kudos to you for that. I think is either good news or bad news, depending how you look at it. We're going to need more more of that coordination. That's like Bill was saying in his presentation too. I think we're going to need to be more proactive in how we figure out coordination between the standards organizations. We need to be less ad hoc about it. A meta organization for the metaverse to figure out how we're going to slice and dice the interoperability problem. Maybe something that we need to think about, and maybe Ismail would be a good forum to talk about that.
Thank you, Neil. That's very generous of you to say that. I think I applaud those on this panel and elsewhere who are, waving the flag. Bill?
Yeah, I'll just echo Neil's, both his remarks. Thank you, Christine, for everything you do. And then also, I would say, rather than starting new standards efforts, seek help from already what's out there. I think that's also contributing to this real harmonization problem, is people want to be the flag bearer of an effort, but you can still do that in existing groups. And groups like Kronos, groups like Etsy, groups that I've been associated with, whether it be ASME, ISO, ISTM, International, they're all very welcoming of new ideas, and you can just go off and run within those channels. And I think they'll pick up a lot of ground. For every standard that's used, there's thousands, well, maybe hundreds that are never touched again once they are passed.
That's a sad truth, and I echo your sentiment. Not perhaps many people are aware of that, but very, very true. Muriel, what are you doing, or how could you summarize what you see today and what you would like in the future?
Well, I will echo Bill and Neil. Really, I want to thank you, Christine, because you're a great asset to any standards organization. Really, I'm very grateful that you participate in the work of the IHTF. You're a great ambassador of standards and the benefits of standards and interoperability in particular. So hopefully, it will be a given in the future that interoperability is a good thing if we want a wider adoption of emerging technologies. And in particular, I think, Neil has been talking about the metaverse. We talked briefly about digital twins. And if we want digital twins and metaverse to be successful, in particular, if we want this digital representation of the real world to be updated in real time, then we need standards, we need people to communicate, we need a shared understanding of the world representation, and that can only happen if companies cooperate through the use of standards.
I'm very sensitive to what you just said, so I'm going to not respond directly. and thank you all for your participation and your great support. And thank you to Neil and Bill for your unstandard time for participating, this exceptional opportunity, and really do appreciate everybody's input. Thank you to the attendees and the people who took the time to listen, and hopefully to listen to these recordings in the future. And I think that's where we end. Thank you, everybody.
Thank you. Goodbye.
Everyone.
Bye.
Thank you.